All right, there we go. Okay, so let's use different. Yeah, what's this, man? Clear page. Okay, I want to use different color. Okay, organic chemistry. Okay, we start from the simplest one, which is crude oil in the ground.
Yeah.
Since you mentioned something that you mentioned that you need, it'd be better if it's something relatable. So, crude oil, let's say this is a ground and there's crude oil underneath. How do you think this is formed?
Crude oil is
How is crude oil formed in the ground? Do you know?
when oil is
Give you a
extracted.
clue, huh?
When oil is extracted directly from the ground, it's called crude oil.
Crude oil is basically oil that is found in the ground.
Yeah.
It could be in the ground that is like under the sea and it's deep sea ocean.
Uh-huh.
Basically, it's a lot of depth. Then you find crude oil.
Mm.
So how is that formed in the first place? Like you hear about stuff, right? Like uh people digging for oil, like in the deep sea, like Russia, China.
Yeah.
I don't know. Yeah. So how is that oil there in the first place?
From the earth.
The answer is dinosaurs. It's
Oh,
basically dead dinosaurs.
literally.
Yeah. Like
Okay, I feel like I've seen
this
stuff on this.
this pen I'm holding, right, is actually made from plastic, which is made from dead dinosaurs. Any plastic that you have around you is made from dead dinosaurs. All right.
Okay.
So basically, that's how crude oil is formed is when dinosaurs die and they get compressed by layers of soil due to soil erosion for billions of years. Okay, and there's a special bacteria that changes them under the high pressure. So from all the flesh and the fats of the dinosaur, you get crude oil. All
Okay.
right. And then fast forward to now, people start realizing they can use the crude oil for to run vehicles, to run machines, and then you start digging, and next thing you know, you have like an oil rig lah. Okay. Can't draw the oil rig underneath the ocean. Like an oil rig,
Yeah.
they will start to build on it. Yeah. And then the pipe goes down, and then they drill, and then they suck the oil out through the pumps. And then uh well my drawing very artistic. And then the ship comes along, they transport the oil onto the ship, all right, and the ship brings the oil away.
Yeah.
Okay. So my question is, what do you do with that crude oil? Where does the ship go with the crude oil?
To industries.
Huh?
To industries.
No, you can't do that immediately.
Oh, really?
You
Oh,
need to
is it
refine it.
fractional distillation?
Yes, correct. So they bring the oil refineries. Okay, we've got a whole lot of them in Singapore, and it's called Jurong Island. Well, all right. And you talk about fractional distillation, that's what's happening in the oil refinery. They are refining the oil. Fractional distillation is actually refining the oil because you can't take this crude oil and then start putting it into a car and then expect it to work. Doesn't work that way. Because
Okay.
crude oil is a mixture and there are too many different types of hydrocarbons mixed in it. It's too crude, as the saying goes, because crude oil is Crude means very impure lah, very raw.
Okay.
So you can't use that kind of oil. It's useless. So you have to fractional distillate it in the oil refinery. All right.
Okay.
So what happens in the oil refinery? Uh, I'm just going to draw like a simple diagram, and it's going to be all very straight.
Does this topic, like when it comes, does it very commonly come out in O levels?
Yes. It can come out in the MCQ or it can come out in the open-ended. The
But will you
very
say
first,
like the questions like carry a lot of marks?
mm, it's like 1 mark, 2 marks, but then you add it up, all the 1 mark and 2 marks, so you can get quite a lot of marks.
Oh, okay.
The,
Because I
the,
realize
the,
this fuels topic is very short. That's why.
are you referring to the whole organic chem or are you referring to this portion?
Just this part, like oils and fuels, biofuels, all these. Like I realize it's very short about oils and all these.
Yeah, this by itself is not a lot lah, but it builds up the premise for later on.
Ah, okay.
Yeah, there's some linkage between what we're learning for this chapter and later on.
Okay, can.
Yeah. Okay. All right. So crude oil goes in here. Then you will heat in a furnace. And this is a fractionating column. You don't have to draw very nice, but when you're doing your own notes, just use squares and lines to draw.
Mm,
Okay. Now at the very top one, uh
cooking and cookings, just cooking.
yeah, fuel for cooking, heating.
Yeah.
Okay, but you also need to understand about the boiling point. Is it the highest or the lowest?
Highest.
It's actually the lowest.
Huh? Really?
Top one will be the lowest.
The top one is the lowest.
Yes.
I have it written here on my notes from one of the lessons that the bottom one for making road surfaces and roofing is the lowest boiling point.
The bottom one is the lowest? Cannot
Yeah.
be. The bottom one will be the highest.
So for making road surfaces and roofing is the highest boiling point.
You think about it lah. Let's think about it lah. If you have two products, two types of hydrocarbons to make roads. Imagine under a sunny day, do you want to choose the one with the low boiling point or the high boiling point?
Higher.
Yeah. So
Because
definitely
if
the
not low,
bottom one.
then the roads will start. It's gone.
Yeah, exactly. Then the roads will just vaporize. Imagine you put some methane on the road. Methane is a gas at room temperature. It's
Because
not going
my
to work.
because what I wrote here was what I was told by teacher who's if not I wouldn't have written it at all. So like that's why I'm like very confused right now. So I was like, what the hell?
Mm. Well, it's okay. I'm here to rectify your confusion, and also maybe he meant something else. I don't know. Anything could have happened at that point in time lah.
Yeah.
So yeah, but whenever you're not sure, right, think about the logic. This is what I want to run through you. You know, you mentioned like everyday things around us, right? So make roads use what? Something that is high or low boiling point. It must be the higher boiling point to make roads.
Mm.
In fact, the things that you use to make road are solid. They are solid at room temperature, which means their melting point is also high. The very minimum requirement is to be a solid at room temperature.
Okay, can.
Yeah. So the logic will always prevail lah. If you feel like something is not right, like Yeah, why is the logic like that? Then that's where you start questioning.
Okay.
So I give you an example. Another common everyday use, cooking. For example, if you go to those steamboat, the kind that they have
Few
uh
canisters.
yeah, the few canisters. Okay, the most common one is propane. If you got time tonight, you go and eat steamboat. Tell
I won't have time.
tell your mom I
Tonight
need
not
to
eating
do
steamboat.
okay. Or some days
No
tell
lah,
your mom I
cause
need to
tonight
do
I
chemistry
having dinner
study.
at home with my mum cause she's flying off tomorrow morning.
Oh, okay.
Yeah.
Well, anyway, you will notice that the fuel canisters being used are propane most of the
Uh-huh.
time. And propane is actually the C3 H8.
Okay.
And those are the top ones, the lowest boiling point. So you can relate cooking and heating, and propane is one of them. And these are the C3 is a very small, it's considered as a small molecule. Actually, generally, C1 to C6 and all that is considered as small molecules. Small molecules will have low boiling point and melting point.
Okay.
Okay, so this is the highest one lah. Then, importantly, as you read the notes, um, the next one we use another color.
Oh yeah, I forgot to ask. For like per month the payments, right? Does it go for as per like lessons or for the month itself?
Um, for this month, it's based on what you are coming down for lah. We'll take it as that.
Like is it like per lessons, cause some places is like, 4 lessons this much or like per month this much, you know?
Yeah, so like what I mentioned, this is your last month and all that.
No
It's a special
because it
arrangement.
will still go into November because my last paper is only on 10 November. So I'm
Yeah.
like, how will this work?
So like let's say uh I saw you this month, right? Is it on the fourth?
Fifth, 4th, yeah, 4th October.
Yeah. Fourth, 16 is today. So this month will still have 4 lessons lah.
This
If
month?
if if I see you if I see you for every Thursday,
Yes.
okay, 4, 16, 23rd, 30, then we have 4 lessons lah.
Okay.
Yeah.
Oh, okay, can.
Then that would be the case lor. Then next month, either 1 or 2 more lessons lor before the MCQ.
Okay.
Yeah. Does that answer your question?
Yeah, yeah, yeah. Thank you.
Okay, no worries. So the next one, if you fuel for cars, we call it petrol lah. What you actually do need to memorize, very importantly, is the order. So the first one is fuel for cooking, then the next one is fuel for cars, then we have feedstock. A lot of people think that feedstock is for cows or sheep or lambs. Actually, it's not. Feedstock is basically uh, a base material that you work with to make like those plastic bags, those detergents. You can also make medicine from this.
Oh, okay.
Yeah, so it's a base. A lot of medicine actually, um, just to let you know, a lot of medicine have a lot of organic structure. So they will usually, okay, you see something like that, right? It means there's carbon in each corner lah.
Yeah.
And then they will usually have some certain functional groups sticking out at the end. So if you change a bit, like for example, you can get penicillin. No, not penicillin. Panadol. Then you change a bit here and there, you can get other types of medication. So a lot of this medication must have a base. It's like a Lego block like that. So a Lego block, no matter what uh shape you want to make at the end, right, you must start with a base.
Okay.
So that base is what they call feedstock. Yeah. So if you're interested in all those things, right, like if you go Jurong, if you go Tuas Industrial Park, all those things, like you will see a lot of pharmaceutical companies over there.
Yeah, I've seen
And
before.
yeah, and they got really huge tanks. Uh, they call it mixer tanks. So inside the tanks, they're actually causing the reactants to mix with each other to get the product out. So
Ah,
they have like a lot of pumps pumping the reactants from one end to the other end to mix and then react and then come out with the product and they package it after that. Um, it's very interesting the whole process. I know because they used to be my customers in the past when I was still working as an engineer. Right? I would go down to many of these places and
oh,
I will actually see how the tanks work So actually, it's quite
oh,
an interesting industry. And the things that you make, the products that you make, then really help to. It can even save people's lives
I've
So
seen cause
yeah.
like my dad will like point out to me or sometimes he may have like pictures cause my dad himself is an engineer.
Oh,
Yeah,
okay.
he's currently
Ah,
still yeah.
what is he work as?
He's a senior engineer at ST Engineering.
ST Engineering. Oh,
Yeah,
ST Engineering.
yeah,
Is the main headquarter
yeah.
It's the one at Tanjong Pagar, I think.
I don't know, he mainly goes to like Tuas there.
Oh,
Yeah,
because ST Engineering has different branches, got ST
yeah,
Electronics, ST Kinetics.
yeah. I think my dad's under kinetics.
Oh, okay. I
Yeah.
used to be at Kinetics as well. Like my very
Ah,
first job was at ST Kinetics.
oh.
Yeah, yeah. So very interesting I mean, ST Kinetics also, I don't know whether can he can bring you in or because of security issues, but
No lah, I don't think can.
there are a lot of interesting things to see there as well.
Yeah.
Yeah. And down there you get to see tanks and weapons.
Yeah, it is interesting.
Yeah. Oh, that means it's at Portsdown, basically. Your dad
Not,
probably goes to Portsdown to work.
not very sure. I only know that he just wants, have to go sailing and to go like
No.
trips. Business.
Oh,
Yeah.
to Israel, is it?
No, he would go sailing sometimes for like his work and then he
Oh,
went to Italy for like training or whatever. His work.
okay.
I also don't
Cool. Sounds fun. Maybe
know.
one day you can join him.
No, he said Italy is boring even though I wanna go.
Italy is boring for work but not for holiday
Maybe.
Yeah, it's a fun place to check out. Lots of
Mm,
cathedrals, a
yeah.
lot of old buildings. Yeah. Okay. Um. So next you have like, let me use a different. So after this you have like after feedstock you have fuel for cooking. Aircraft engines. Um. Another name for this column. So you have column 1, 2, 3, and 4. Another name for this column 4 is actually kerosene. All right, and kerosene actually is used in like those olden, those really backwater countries where they hardly have power grid, electrical grids or what. They use kerosene to keep themselves warm at night. They use kerosene to cook. They use kerosene to light up the place. Kerosene can also be used for aircraft as well. So yeah, that's about it. Nowadays, of course, everyone is trying to move away from kerosene. In the past, for example, Bhutan, a lot of because Bhutan is not a very technological advanced country. It's the happiest country in the world, but they're not technologically advanced. So a lot of people actually they use kerosene to actually, cook, keep warm. So the
Mm.
Bhutan king decided that hey, you all should stop doing that. So he actually built a hydroelectrical dam and he used the electricity from there. He actually built all the wiring and all those things just
Oh
so that
wow.
they will stop using kerosene at home.
Oh, that's
Yeah.
interesting.
Yeah, because with that that's how they maintain carbon neutral overall. Bhutan is the only country in the world that's carbon neutral. Carbon neutral means that the carbon you produce is offset by the carbon that is being absorbed by your trees and your forests and your ocean. So
Oh,
yeah, and not even today, this is news for many, many years. Even today, there has been no other countries that can do that.
oh wow.
It's very interesting.
Okay.
So one of the things they did was to remove kerosene because it's a very backwater way of uh cooking and keeping yourself warm and all those things.
Oh,
Yeah. So the next part here, number 5, it will be diesel. So in Singapore, there is diesel and there's petrol. Petrol will be this one here. This is petrol.
okay. What's the
Diesel.
difference?
The difference is diesel is a far better, more efficient engine compared to a petrol. Like for every liter of diesel that you have, you can actually go further in the distance. A diesel engine is
Oh,
actually much more efficient. However, a
okay.
diesel engine has stuff that you don't want to be put out too much in the atmosphere. The pollutants that come out from diesel engines are like a lot more harmful lah. So government try to limit that in a way.
Ah, okay.
Yeah. So like in the past, a lot of most commercial vehicles like trucks and lorries are diesel engines. They run on diesel. And the typical cars that everyone has, like the saloon cars, the MPVs, all that, they all run on petrol. So that was the idea. And nowadays, that difference is getting lesser as more of the cars are actually going towards electrical or hybrid. But having said that, there are a lot of older trucks and lorries on the road that are still running on diesel lah. But
Oh,
Singapore aim to actually remove diesel or petrol uh in the near future. I think it's 2030 or something, I can't remember. Like completely run on electrical. Yeah. But having said that, that's diesel for you and it's lower down. It's a better type of fuel compared to petrol but it just produces more bad stuff.
okay.
Yeah. And then number 6 is what?
Number 6, lubricants, polishes, and waxes.
Yeah. So if you think in your mind, lubricant, wax, what state do you think you're in?
Liquid.
They are somewhat between solid and liquid, like
Because it
in a
wouldn't be
semi.
very like liquidy and
Yeah, yeah. So naturally, the boiling point here will be very high, ma. The melting point, boiling point here will be very high
oh, okay.
because they exist in that kind of state.
Okay, can.
Then the last part is the road, lah, road and roofing.
Okay, can.
Yeah. So you got to take note, lah.
Okay.
In any case, if you look at your notes, on the right side, it says hydrocarbon with increasing number of carbon atoms and boiling points.
Yeah.
Yeah. And it also says the higher the boiling point, the lower the column.
Yes. Yeah. The
Okay?
lower the col or lower the column. Okay, okay, can.
Yeah. Okay, ah?
Yeah, can.
So moving forward, the next part based on this one is about the physical properties
Okay.
that is essential to remember. And these physical properties will be repeated for every other subtopics that comes after this. Meaning to say the trend is very similar. So if you learn this one time, you will be able to repeat it again
So it's
for the other
important to know
topics.
the physical properties.
It's important to know the trends lah.
Okay.
So example of a trend would be uh boiling point. Ooh, this is not a good color. Boiling point, melting point increases as the size increases. The size refers to the molecule size. So over here, right, the molecule size increases down the fractionating column. As you go down, molecular size increases. So example would be like methane is at the highest here. Then at the bottom, you could be looking at C80. Methane is one carbon, and the bottom is 80 carbon chain. So that is what they're referring to when it comes to molecular size. Okay,
Okay.
then it's important to understand the reasoning. Why? So as molecular size increase, sometimes it's good to write short form as you're making your own notes. It's good to write short form.
Yeah, I always try to just summarize it in as little words as possible so that I don't
Yeah,
have to think so much.
yeah. Then you can say the intermolecular forces of attraction IMFOA, again short form, is stronger. So I just put increase. Then more energy required to
Okay.
overcome. Now, do you find this familiar?
Yeah.
How is this? What chapter is this related to? Earlier topic,
Is it kinetic bonds?
kinetic bonds
Like
is
something.
related to chemical bonding.
Oh, chemical bonding. Sorry, not kinetic bonds. Sorry. Oh my god.
Yeah. And that is chapter 3, I think.
Yeah, it's about the covalent bonds, right?
Yeah. So these are all hydrocarbons, and hydrocarbons are simple covalent molecules. So you can actually put here, like when you're doing your mind maps, you could ask yourself, hey, this one sounds familiar. Where is it from? And I tell you, like one of the secret or one of the ways to actually improve in chemistry is connections, connecting the dots. The more you can connect with other topics, the better you become. Because
Okay.
when they test you, right, they are going to do that way as well. The questions may have more than one topic inside. So the more connected you are with the topics, the more prepared you are to handle such questions.
Okay.
Yeah. Okay. Then the second one, tell me something about flammability. Is it
Flame.
more flammable or less flammable?
Like, what is last name?
As you go down the group, as you go down the fractions,
Uh,
are they more flammable or less flammable?
less.
Less flammable. So again, you can use logic. Think about it. Methane, is it very flammable?
No.
It is flammable. Very flammable. It's used for cooking.
Oh yeah, oh yeah.
So you want something that is flammable so you can cook faster, right? If it's
Yes.
less flammable, then it's going to take you a long time to start the fire.
Yeah, to
Then
boil
that's
and
going
stuff.
to, yeah, then that's going to delay your cooking. Whereas you think about it, road surfaces, roads and roofings, do you expect them to be flammable?
No, it's not.
No,
It's
right?
supposed to be able to sustain like very high temperatures.
Yeah, exactly. So the flammability should decrease lah. Less flammable, down the fractions. And what is the reason?
Um, you follow the boiling points.
It has nothing to do with boiling point. It's about the percentage mass of carbon.
Okay.
So the background is this. If you want to burn something, example, you want to burn methane, you burn it with oxygen and you get carbon dioxide and water, which by the way is the most common form of combustion that you have.
Yeah.
Okay? It's not balanced, so take note. But I want you to the whole point is not the balance equation, but the whole point is to take a look at the bonds that we have here. Oh no, this is not Mickey Mouse. Hang on. H2O is the one that's Mickey Mouse. Yeah. Okay. So for this to become this, it needs to break through all the CH bonds, you see. Let me draw the H inside. It needs to break through all the CH bonds to become this. So because there is very little bonds to break, so it's easy to form this, which makes methane very flammable lah. Whereas if you look at things like um but actually those are still quite flammable. Let's say you look at a 10 carbon chain.
Okay.
You would have to break all of these bonds. Break, 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 break. Then you can form this. So this will be less flammable compared to methane. Because in order for something to be flammable, you need to break all the bonds to get the carbon dioxide.
Yeah.
Therefore, methane is the most flammable compared to all the larger molecules.
Okay.
So the reason being is percentage mass of carbon increases as molecular size increases. Then all of this I mentioned to you is just for you to understand better lah. But I think for you, you just mentioned that it becomes less flammable. That's it.
Okay, can.
You don't have to talk about breaking of the bonds and all those things. It's just background knowledge for you to try to understand the knowledge, the
Okay.
content. Yeah.
Actually, is there like do you have any worksheets or anything that have like the keywords for each certain topic? Because I know that chemistry you have to be very specific with the keywords because that's what gets you the marks. Is there something like with like all the keywords and stuff for me to take note of? Or is it just go through the notes?
Um, what I would do is okay, basically when if I'm going through you something like this, what you see right now, it means that it will come out. Like
Okay.
it has a chance of coming out. There are certain things I actually skip just now. So actually, yeah, this does come out lah. if that's what you're asking. Do I have worksheets on that? The TYS questions that you do actually is a very good place to start.
Okay, can.
Yeah. Okay. Um, I'm gonna go faster a bit. So next you have high viscosity, and it's about the IMFOA is stronger as molecular size increases. It's similar to boiling point. Are you familiar with the word viscosity?
Yes.
Okay, can you name a fluid that is viscous?
I'm familiar with the word part, not like the whole thing.
Can you name anything that is in your that is around you that is a viscous fluid?
There's a what?
Can you name anything around you in the kitchen or something that you're familiar with that is a viscous fluid?
Um, not oil, right?
Not really. You
Uh,
can example like milkshake lah. Milkshake is considered viscous.
is it viscous?
Okay?
Is something that is not like watery, but it's also a bit thick, is it?
Difficult to flow. That's the meaning of viscous.
Oh, honey.
Yeah. So you gotta understand about viscosity lah
Mm,
in order to remember this. All right.
can.
So low volatility. Again, I'm just gonna go through this quite fast. Talk about the IMFOA increase. So more heat required to break. Low volatility is related to boiling point, melting point. These two are related.
Okay.
Because to be volatile means that you can evaporate easily. If you have a low boiling point, melting point, you can evaporate easier. So it's similar to uh, melting point, boiling point. Okay. Whew. And we can skip a few. You can read the rest. Oh, this
Okay.
one does come out. Bioethanol. Okay, the next part is something that you need to know. Bioethanol. What do you know about it?
Not much.
Okay. How do we get bioethanol?
From biofuel?
Such as?
Plants or
Starts
animals?
with S. No, it starts with S.
Yes. Biofuel.
Sugar.
Oh,
Okay, from sugar you can get ethanol. Can you tell me what is the process? What is the process called?
what actually to create bioethanol?
Yeah, from sugar the ethanol. Starts with F.
Fractional distillation?
No, it's fermentation.
Ferment fermentation?
Yeah,
Sugar can actually turn into ethanol.
yeah. That's how you get wine, by the way.
Oh, I mean, yeah, that one I know.
You basically take grape and you put yeast inside grape, you fermentate it, you get a wine 6 months down the road.
Yeah.
And you're expected to remember the conditions, which are yeast,
Dark.
37 degree,
Oh, that's true.
and what's the last one?
Do you have to be very like specific with the degree?
Yeah.
Oh,
Yeah, because if it's too high, the yeast will die. If it's
oh,
too low, the yeast will die too.
okay. It's like
Yeah,
sourdough starter.
yeah. And the last condition is no oxygen. Because if you introduce oxygen inside, your ethanol will become something else. Do you know what?
What?
If oxygen is present, what will you get? You become oxidized. When ethanol is oxidized, what will it become?
Oh my word. Ethanol oxygen.
When you leave the wine outside for too long, what will it become?
It will
What will it
go
taste like?
bad. It will go bad. It will be sour.
Sour. What does it remind you when something is sour?
I think of acids.
Yes. What acid would this be?
Ethanoic acid?
Ethanoic acid. Okay?
Yeah.
So you got to draw relationship. This is the key to building a mind map. Okay?
Yeah, can.
So why is bioethanol important? So when you do this, um, through fermentation, okay, to form sugar, right, is photosynthesis.
Yeah.
So to form sugar, you will need CO2 and H2O. So this process here, because carbon dioxide is being absorbed, is a carbon capture. Meaning to say, you absorb the carbon dioxide from the environment. Okay, then you do this. Then over here, you can use the ethanol for combustion to give you the carbon dioxide and water back again. So this one produces it's what they call carbon production. So basically, right, bioethanol is often the fuel to talk about because to produce it, you can capture the carbon. Then to use it, you can produce the carbon. So the carbon captured and the carbon produced is equal. So therefore, there is no net carbon dioxide produced uh, or no net carbon dioxide released into the air. So that is important because greenhouse gas is a big thing nowadays. Climate change, global warming. How is it that we got so many months of hot weather, so dry, so hot, and night also so
Yeah.
hot, cannot sleep? Why? Because the climate is changing. Hot weather is getting hotter, colder weather is getting colder. At this rate at which we are going on, it might even snow in Singapore one day. It might
Okay.
happen. There's a possibility.
It's a possibility I'll be very happy about.
Yeah, but wait till the summer, wait till the hotter months come. Then it's even
Yeah, it can
hotter.
get very bad. It's really very, very hot in some summer for other countries.
Yeah. So like California, for example, is slowly becoming a desert
Oh my god.
because of the climate change.
Yeah.
So this whole idea of a bioethanol fuel where there's no net carbon release in the atmosphere is something that deserves to be talked about lah. Because we are always looking for something that affects the environment to a lesser extent.
Yeah.
Okay? But however, there are disadvantages lah. So the advantage is that uh, as what I mentioned, less greenhouse gas produced, and bioethanol, you can get it anytime. You don't have to wait for billions of years to form. Crude oil, on the other hand, you have to wait for billions of years
Mm.
because it's dead dinosaurs. So it's non-renewable. But bioethanol, you can you can use you can obtain it quite easily. Just grow some sugarcane, grow some plants, and then get the sugar from it. So
Yeah.
it's not as renewable. Yeah. But the disadvantage is that you need time to happen. You need fermentation takes about 6 months. You need to grow the plants. So that takes a lot of space, crops, trees. You need to clear the land for the crops to grow.
Yep.
So that is the downside of it. Okay? Can
Yeah, can.
Hmm. Moving forward, the next part is homologous series. So we are going into each of the fractions, or rather, in this case, the first fraction.
Mm-hmm.
Okay, the first fraction will contain hydrocarbons. By the way, what are hydrocarbons?
Uh, oh my god, can't remember. Wait, hydrocarbons, fuels,
Compounds that contain
carbon.
what? What's this, man? Contain only?
Hydrocarbons, is it under the periodic table chapter?
No, under the organic chem chapter.
Oh,
I think you got confused with halogens.
oh yeah,
Halogen is
yeah,
under
yeah, yeah,
purity.
yeah.
Yeah.
Hydrogen and carbon.
Yes, correct. Hydrocarbons are compounds that only contain hydrogen and carbons. Okay. And the most common hydrocarbon, as what I mentioned before, methane.
Yeah.
Okay, methane is a very flammable fuel. Methane is CH4. Now, methane is also part of a homologous series. Can you tell me what is the name of
Uh,
that homologous series? Starts with A.
uh, alkanes.
Alkanes.
There's alkanes and alkenes, right?
Yep. How do we know that methane is an alkane and not an alkene?
Because alkanes will only contain carbon-carbon single bond, and then as for alkenes, it will have one or more carbon-carbon double bonds.
You will have at least one, yeah.
Yeah.
So if you draw methane out, it will look like this, and they're all single bonds. There's only one carbon, so it's definitely not an alkene. Okay?
Yes.
Now, this CC single bonds is also known as its functional group. A functional group is basically like the surname of the family. Like your surname is PEK, right?
Yes.
Pig. So everyone in your family is supposed to have the last surname lah, Pig lah. Which means that in a way, your family is a homologous series because you all have the
Oh,
same surname,
okay.
which is in this case the functional group.
Okay.
You can think of it that way lah. Okay, homologous series is like a family, and the functional group is like their surname. It's the group that distinguishes themselves as part of the family. Meaning to say, if methane has carbon-carbon single bond, then it's definitely part of alkane.
Yeah.
Can you tell me the general formula of methane?
Isn't it just CH4?
That would be the molecular formula.
Oh.
General formula is a common formula that applies to everyone.
Oh, is it the wait, let me CnH2n plus 2.
Yep.
And the numbers is the amount of like bonds, is it?
No, the N here is the number of carbon atoms.
Ah, okay. Number of
So,
carbon. Okay, yeah.
yeah. So for methane, right? Can you tell me what will be the N value for methane?
For methane, it would be for the using the general formula, right?
Yes, correct. You look at methane, how many carbon atoms are there?
For
Carbon atom.
eh
Carbon atom.
one.
So N will be equals to what?
1.
1.
And then
So
H will be 4.
yeah, if you sub N equals to 1 here, then you get 4 lah. So you get CH4. Okay?
10.
What happens if you sub N equals to 2?
N equals
Not here. Yeah. What happens if you sub N equals to 2? What will you get
a whole
into the formula?
different alkane.
Huh? So
Into
you get what? C2H what?
H4.
Are you sure? Check again.
Eh? From the thing, the C2. Wait, which one is being changed into 2 just for the carbons there?
So the N here you sub 2.
Yeah.
This N also is sub 2.
Oh. 2 and then 2 times 2 plus 6.
C2H6. That is the second member of the family.
Yeah.
Now, can you name the member?
Ethane.
Ethane. Okay?
Yeah.
Now, what about N equals to 3?
N equals to 3. Then it will just become propane.
Yeah.
And then so on, so on.
Yeah. Okay.
Yeah.
Can you tell me what is your boiling point and melting point like as you go down the group?
Melting point and boiling point.
As you go down the members, will their melting point, boiling point increase or decrease?
Uh, the melting boiling point will increase.
Increase. Now you can fall back to what we talked about earlier, which is why I say it's important. You see this?
Yeah.
This is what we talk about. Same explanation. That's why I say if you understand and memorize that table, you can use it for other topics that come along, other subtopics of the same organic chemistry uh, section.
Okay.
Yeah. Okay, so this is a opening introduction to homologous series. All right.
And
Can you name the other homologous series?
alkenes.
Uh-huh.
Alkene to contain ethene, propene, and butene. So
Yeah,
it's
what
like
will be the
for alkenes, it's just that you change like the behind the letters.
Yeah, correct. One letter change only lah.
Yeah.
Can you name the functional group for alkenes?
For alkenes is C2H2N.
Functional group.
Functional group.
Functional group is a surname. Like this one, CC single bonds is functional group for
Oh,
alkane.
carbon double bond.
CC double bonds. What's the general formula?
C2H2N.
CnH2n, not C2H2n. Huh?
Sorry,
CnH2n.
zero.
Yeah. So I noticed you got a bit confused between functional group and general formula. It is important to be able to differentiate them because you are looking at a 1 mark question.
Okay, can.
Write down the functional group of alkene. Then suddenly your answer is CnH2n, which
Then
is
it's
not
just
correct.
marks gone.
Yeah, these
Okay,
are
can.
very easy marks to get. Okay. Alcohols, what is the name of the functional group?
Alcohols. Alcohol. Oh wait.
It'll be called hydroxyl,
Yeah.
and the functional group is OH. So example would be ethanol. Ethanol is CH3 CHOH. C, let's see, oh, CH2, yeah, yeah, CH2OH. So for example, this is ethanol. Okay, we should look at that. The hydroxyl refers to this one.
Okay.
So whenever you see a compound that has OH inside, means it's a alcohol.
Okay.
Again, it's a surname.
So only OH then is alcohol.
Yeah. And if they really want to make it tough for you, how much should I say? Let's see. If they really want to make it tough for you, they could actually change it to something like this. So this part will be an acid, and this part will be alcohol.
Okay, can.
Such a compound also exists. So be careful lah, that's what I'm saying. Which brings
Okay.
me to my next point, carboxylic acids. All
Yes.
right, which goes something like this. Okay, that's a functional group. That's called a carboxyl. And here's the thing, it may seem to be alcohol, because you got the OH here. But because of the C double bond O, you have to compare the whole thing. So what I'm trying to say is this is not alcohol. Only when you have something like that, then it's alcohol.
Okay. So only if it's OH, but no other order, just OH.
Yeah, you see a
Okay.
C double bond O here is an acid, not an alcohol.
Can.
Yep. So I'm just gonna fast forward a bit, blah blah blah. Okay, here's what I'm gonna do. I'm gonna talk about alkane now, which is very similar to alkene.
Yes.
Whatever I do for alkane, you could try doing on your own for alkene. Okay,
Oh.
so I'll show you what I mean in due time. So we did actually do some exercise. I mean, we did go through a bit about alkane. All right, CnH2n plus 2,
Hmm.
general formula, CC single bonds. Alkanes are also known as saturated hydrocarbons. Do you know why it's saturated?
Cannot remember. Like
Saturated means
diluted
this,
down.
huh?
Okay.
That's what I mean saturated. That means only contains CC double bonds. It means no, only contains CC single bonds. It means no double bonds. That's the meaning of saturated, which tells you that alkenes will be what?
Unsaturated,
Unsaturated
which would be double double.
because of the CC double bonds.
Yeah.
So do take note on that. Um, let's continue. The first thing you want to do is at least know the first four members of alkanes. So I'm just going to draw it out. Now, if you see me drawing the bonds without the hydrogen, it just means that there's hydrogen there. Lah.
Okay, can. Cause you don't want to keep drawing the H, right?
Yeah. So I'm going to draw for this. So the very basic that you need to have is to know the first four members, the names, the structure. Okay.
Yeah.
And then the properties. So the physical properties will be as per usual in that table just now. Um, over here, high viscosity, low volatility, all that, all the same. So just repeat. Okay, the next part is the chemical reaction. That part is important. So let's go through it. The
Okay.
first one is combustion. That one is very simple lah. You
Yeah.
plus O2 to give you CO2 and H2O. Make sure you balance, and that's it.
Can.
Now, if you learn quality, and if you learn air quality, right?
Mm-hmm.
Mm, wait, ah. What happens during incomplete combustion? What are the products you'll get?
1 second. Incomplete combustion. I know I had this written down. Oh, carbon monoxide.
Yes, very good. Do you know there are other things?
Oh no, I only have carbon monoxide here.
Okay, there'll be soot, which is carbon. And then there'll be water lah. Okay? Now, have you ever burned a candle flame?
Yes.
What is the color of the flame?
You burn it.
Yeah, what's the color of the flame when you burn a candle flame?
Orange?
It's orange, it's a yellow flame, yellow or orange. Now, if you look at the flame closely, sometimes you can see something else near the flame. You can see spots of black stuff. It's smoke lah. Have you ever seen that before?
No.
Okay, try
Oh
burning a
yeah,
candle
I
tonight.
did.
Now, if you recently did 7 months, do you like burn incense paper during 7 months?
No, I don't. I do not
Okay,
do settlement.
sure. But if you notice people doing that, there's a lot of black smoke coming out.
Yeah.
Yeah, the reason why there's smoke is because there's soot. It's black. Carbon by itself is black. So
Yeah.
the takeaway from this is that when there's not enough oxygen,
Carbon
when
is
you
the same
burn
thing in our
anything,
pencils, isn't it?
yeah,
Yeah.
it's graphite, but it's a different type of carbon. Carbon
Mm.
have different forms. The one that's in your pencil is graphite. It's a form of carbon. Okay? By the way, you can eat a pencil lead. I mean, don't try it, but graphite is safe to
Uh,
eat a bit.
okay.
Yeah, fun thing, fun thing to know. Graphite is
Okay.
safe to digest
I've only
because they
ever
sell graphite.
digested paper intentionally, but yeah.
They actually sell graphite at the pharmacy. I mean, they sell carbon pills at pharmacy
Oh yeah, I
for,
know.
for diarrhea. That one is just pure carbon. Just take
Yeah,
it
I
and
have
then
those at home as well, yeah.
yeah. So those are all different forms of carbon, right?
Okay.
Okay. So the next part is very important. It's called a substitution reaction. Example, they will give you it's like methane with chlorine.
Mm-hmm.
What product can you possibly get? And what is the condition? They will always ask for that somewhere.
Um,
Do you know?
not very sure.
UV light.
Ah, okay.
So when it comes to organic chem, alkane, alkenes, there's always condition that you need to know lah. Okay, in this
Okay.
case, one of the H will be removed and substituted with a chlorine. So you get this. And then the chlorine will combine with the H to get HCl. That's why
Okay.
this is called substitution.
He takes over the other one.
Yeah. It's like you're in a basketball match and then somebody asks you to time out and then you get replaced by another person.
Yeah.
Substitution.
Okay, can.
Now, taking note that this process can continue again. If there's more chlorine, another H will be substituted. And then you'll get this. So the process can repeat itself, provided you have enough chlorine, chlorine gas. The final product will give you carbon tetrachloride.
Okay, can.
Okay. Another thing to take note that this is slow. It's very slow. It takes like a few hours for this to happen, even with sunlight.
Okay.
Yeah. Useful information to take note when they are comparing with alkene, because they will always compare with alkene.
So I just say that it's slower.
Yeah.
Okay, can.
Okay. I'm gonna skip past the isomers part. Because you are combined science, you won't be you are combined science, right?
Yes, it is.
Okay. You won't be tested on isomers. So I'm gonna skip that. Okay. So for your homework, what you can do tonight, since you mentioned that you like to like to read up stuff and all those things, do the same for alkene.
Okay,
Alkene
can.
got a lot more stuff.
Yeah.
So what you need to do is first write down the four members, talk about unsaturated, functional group. So once you're done with that, then physical properties as well. The same thing lah, the melting point, boiling point decreases down the group and all those things. Then this one is a difficult part, which is chemical reactions. So what are the chemical reactions? The first one is the common one, which is combustion.
Mm-hmm.
Also the same thing, carbon dioxide and water produce. Then there's incomplete combustion, which can cause soot, carbon monoxide and water to be produced. Alkenes generally will burn with a sootier flame. Alkenes burn with sootier flames, meaning to say the flame is blacker because got more higher percentage of carbon. Example, this is ethane and this is ethene.
Also both eating. Oh,
No, this
18
is
and 18.
ethene, this
Oh,
is
okay,
ethene.
okay, sorry.
Yeah. So this one is 2 times 12 over 2 times 12 plus 6 times 1. I'm talking about percentage mass of carbon.
We have to remember the general formulas, right?
Yeah,
Memorize it.
yeah,
Okay.
yeah. Then this one is 2 times 12 over 2 times 12 plus 4 times 1. So because of this part, the denominator is smaller. So there's higher percentage of carbon, which means that it burns your sooty flame.
Okay, can.
Because remember, soot comes from carbon. More carbon you have, more soot produced. Then there's addition reaction.
The soot can also be from incomplete combustion, right?
Yeah, correct.
Okay, can.
So there's addition reaction, and there are different types. One is the steam, which is hydration. And then the common one is hydrogenation. And you will find a relationship with margarine. So that can be taken from your notes. I encourage you to read that
Okay,
and put
can.
in. Then got conditions. There are also conditions to take note. For example, you will be using a nickel catalyst for this. And the degree should be 200. It says high temperature and pressure. Should be 200. Yeah. And then there's bromination. So bromination, bromine gas is a halogen.
Okay.
Remember just now we did something with the chlorine, this one. You can also do the same thing with a bromine because it's the same group. They are all group 17,
Yeah.
meaning you should expect the same results. Now here's the thing, bromination does not, no UV light needed, and it's fast. Okay, it can happen very fast. You don't need to wait for the reaction to slowly take place. Okay, and we often use this to distinguish between alkane and alkene. Crucial question, commonly asked.
Can.
Okay, so the idea is that if you got, I give you an example lah. This is the level 1 basic question they will ask. Uh, where did my text go, man? Oh, this is so weird. Huh. Okay. Um, two unidentified identified containers were found to contain either alkane, wow, I'm getting so triggered right now. Wait, because this Zoom not very good when it comes to writing stuff. Alkane or alkene? Uh, yeah. Determine a test to differentiate them. Something like that. So the straightforward answer is, what do you think is the answer?
Uh, is it using the slow or fast thing? Can we use that?
Yeah, based on that, you can add bromine water to each of them. The container containing alkene will what? What will it do?
It will be faster than the other.
Will decolorize bromine almost immediately, while the other container with alkane, what?
Will decolorize much slower.
Will not
Okay.
decolorize it. Yeah. Do you know why?
Why?
No UV light present.
Ah, okay.
Yeah. Okay.
Yes.
Whew. There's so many more stuff. Okay. So I fast forward, you go and read, make sure you read stuff about that.
Yeah.
What are let me give you a guide. What are the things you need to work on? Let's talk about cracking.
Yeah.
Okay, why do we crack and how do we crack? Do read about that and make your own notes, huh?
Yeah.
Okay. And the conditions, there's also conditions for cracking. A lot of conditions for this topic. Example, aluminum oxide catalyst, high temperature, 500 to 700 degrees, pressure of one atmosphere.
So again, have to be very specific with the temperatures and stuff.
Sorry?
So again, have to be very specific.
Yeah. Yep. Yeah, chemistry is like that one. It's memorizing.
Yeah.
Okay, then after that, there's polymerization. That's how you make plastic bags.
Yeah.
The most common form is polyethylene, most common form of plastic bags. Um, then you have to work on alcohol. Okay, again, the same thing, functional group, uh, general formula, physical properties, and we spend some time talking about ethanol. You will find fermentation in that topic as well. Um, Yeah.
Can.
Chemical reactions. We need to know this. Yeah. Yeah, all the chemical reactions.
Okay, can. So these ones are to like read up on
Read out on your own and do notes.
Yeah, can.
And then I'll test you on the notes.
Okay.
Yeah. So, like, once you do that, right, you can start doing the questions already.
Okay, can.
Yeah. Because you have the knowledge to do so.
I have done the questions, just that just sometimes I just try to revise them also, and like I'll just
Mm.
maybe like I'll cover the answers, then write it on the blank piece of paper.
Okay. And let's not forget, there's also carboxylic acid as well. We went through a little bit under ethanoic acid. It's the most common one. And having said that, take note, ethanoic acid, right, is also vinegar. And therefore, it behaves as an acid.
Yes.
Uh,
Sorry.
so meaning to say that if you take an acid and you react with a carbonate, what will you get? You get salt plus carbon dioxide plus water. So ethanoic acid will give you the same thing. Example, CH3COH plus sodium carbonate. Then it will give you sodium ethanoate plus carbon dioxide plus water. This is similar to hydrochloric acid plus sodium carbonate. What will it give you?
Uh,
You must remember your acid.
basis reaction.
So you can see here, your Na goes here. Now over here, your Na will go here, and then your chloride goes to here. Okay, you still get the same products. Meaning to say, ethanoic acid will behave similarly as any other acid. Whatever stuff that you learn from acid, alkali and salts, that topic can be reused again here.
Okay.
Acid, bases, salt. So while you are going through your carboxylic acid, it will also be good to go through the reactions of acid with metals, base, carbonates. What else? Do. Ester homologous series. That one no need to cover because you will not be tested on ester. Yeah, so the last part about polymers, your topic also covers polymers.
Yeah,
And the
I was
most common
revising
form,
some of it also the other day.
okay, good. Then can you tell me what is the structural formula for polyethylene?
Polyethylene.
How do I draw it out?
Is it the one
What's
with
inside?
the um uh, for what? Polyethylene.
Yeah, polyethylene. What's inside the bracket?
How do I say it? For polymer, it's like there will always be two repeating units, right?
May not be two repeating units. Okay, they can ask you for three. They can ask you for one. What I've drawn is one repeating unit. What about two repeating unit? How do I draw it? I just need to copy and paste for another time lah.
Okay.
Can you see this? There's two repeating units. This is one. This is two. And always put the bracket N here to
Okay.
indicate that the chain continues indefinitely. Or definitely lah. Okay?
Yeah, can.
Can you tell me what type of polymerization is this? Starts with A.
Um, A.
Yeah. It's called additional
Or
polymerization.
addition polymer formed. Oh, okay.
Or addition, not additional, addition polymerization.
Okay.
The other type of polymerization is called condensation polymerization, which I believe is not in your syllabus, not for
Yeah,
combined
it's
science.
not here.
For pure science, yes. But this one is like, hey, I expect to draw this out. A common question will be drawing this out.
Yeah, can.
In fact, I just went through that with my student yesterday.
Oh.
Yeah. And she didn't know how to draw.
Oh.
Yeah.
Is she also taking O's?
Yeah, yeah.
Oh,
Actually, they were supposed to come today, but they got English O level,
yeah, it's today.
so they can't make it. Now, I'll give you an example. When it comes to polymers, so let me give you something like this. Maybe I should make it harder for you.
Uh,
Now, when it undergoes addition polymerization, what will you get? as a repeating unit. Let's say you are asked to draw one.
Repeating unit.
So very important, the key thing is you must make this presented into something looking like this. That is to say, you must fill in the brackets here. Oh, I shouldn't have this. Yeah, since you got a pen, right? Why don't you write on it?
Uh,
Why don't you fill in the boxes?
okay.
Can you draw on it?
Yeah.
Yeah, fill in the boxes.
I don't know, I'm so light. Help. Condens- Wait, is this? Oh, but then you say condensation isn't part of the syllabus for me though.
This is not
Oh,
condensation.
okay. Sorry, because I saw the top, I thought it was like, I was like, oh. Is it that way you have to rearrange it to be like the ladder or something?
Yeah, you can think of it as a ladder.
Uh, S, H. Is it?
Um, then my question is, what happened to this one? Where will it go
What?
then? What happened to the CH3?
H. It will be like, it will polymerisation.
Okay, so let me help you. So this one will go here. So like this one will go to here. This one will go here, and this one will go here. This one will go here, and it will become this CH3. You can group it together like that.
Oh.
So when you draw this out, what you need to do is you remove that double bond. You will draw the H, all the H's here, but very crucially, the last part here will be CH3. And there will be the answer. Okay? Same thing, what happens if I were to delete one and put F? Then this one will no longer be H, just be F. Okay? And if they ask you to draw two repeating units, it's very simple.
No, okay. Shh. Shh. Which one again? Sorry.
If they ask you to draw two repeating units, then it'd be very simple. You look something like that. Yep.
Oh, so you're just repeating it over and over, can. Will they
Yeah,
tell you like how many times they want it to be repeated or like
yeah,
is
they will tell you.
okay.
They'll tell you to draw how many repeating units. Just follow.
Okay, can.
Okay, so that's all I have for organic chem today. Like what I said, um, two things you can do. One is be sure to write out all the stuff for alkenes, alcohols, carboxylic acids, polymers. I did some polymer for you, but there's more information there. And try the TYS, like all the questions, which is like a whole bunch of questions.
Okay,
I
can.
think there are, I think there's like 46 MCQ or something like that. I can't remember.
Not sure, I will have to check.
Yeah, there's quite a bit of questions lah. I mean, the whole organic chem section in the TYS is quite thick. And I'll see you next week.
Okay, can. Thank you so much.
Yeah.
Okay.
So